Okay, hi guys. So I'm Jerome and this is Wendy and we're talking about sports scheduling. So why did we choose this topic? Basically was because there's a lot of revenue involved. Like based on the TV schedules, right, the matches that you play, depending on the time, it actually matters how much money you make. So we see that there's a round robin pattern to like chess, sports, and even like esports these days. So yeah, when we first thought about it, we thought that it was actually quite easy, that we can just do try and error. Then we just create a table and try to fill it in. And then we realized that there will be cases where you have odd number teams and you just introduce a dummy team in like a bye so the team doesn't play for the week. And this is when a team has to play like one game a week and can only play each other team once. However, when we have more than like if we have 20 teams, right, that will be like 380 games to schedule, and that is a big problem. So we found this burger system is by some Austrian chess master where he actually has this table for up to 30 players and you just feed the teams into a table. But then it will not work for more than 30 teams. So next we found this greedy search algorithm. And basically what happens in greedy search is that it will go like you'll schedule team 1 first, so you will go from the entire row down, then after that you will schedule team 2 and so on and so forth, and such that the team does not play more than once a week. Yeah, but this will actually introduce a problem where you would see team 4, right, for example, they will keep playing team 1, team 2, team 3 in the same sequence. So this problem, people term it as a carry-on effect where you keep playing the same people over and over. That means in the same order. So to solve this, Wendy will share with you a method.
Okay, so yeah, basically this is the Kirkman tournament, the circle method. So it's derived from this Kirkman's school goal problem. So imagine 15 young ladies walk out of school, 3 abreast for 7 days in succession, and then the requirement is that that you arrange them daily so that no 2 of them shall walk twice abreast. So what it means that every day they will walk out once from Monday to Sunday, and then at the same time they cannot walk out with the same person again. So as you can see, this GIF over here. Okay, let's wait for it to turn to. Okay, never mind. Yeah, so you can see the center. Can I borrow a pointer? Yeah. You all can see the center guy, right? He's like the pivot point. So the circle will turn according to him being the pivot. So you can see that you actually have 3 different people for each of the day. Yeah. Okay. So a easier way for you to understand is like take the FIFA World Cup Group A, for example. Yeah. So the number of matches is 4 choose to 6 matches, and then you have 2 matches each day, and it'll spread out over 3 days. So basically, you can see it like by using that method, for 2 teams each that they need to play with each other and they shall not play with each other again, you end up getting 6 matches, and this is the team matchup. So you can try it yourself in this website, yeah, or you can just Google and you can find out a lot of ways to do it. Yeah. So anyway, this is another interesting tournament way of doing this. The Swiss tournaments matchup. So what this actually does is each round, teams or players they are matched up with another team or another player based on a pairing method, and then every win will award you a Swiss point. If you don't win, you don't get any points. So group pairing is then used to decide who plays next, and the pairing method is slaughter pairing. So usually the people with more points will play the one with lesser points. So let's say if there's an odd number, then a bye is given. So a bye meaning this player will fight against a pseudo or like a non-existent player, which means he gets a walkover. So the algorithm here I'm going to explain is liquid. I don't know how to pronounce. So Lick-Vine's algorithm. So basically what it does is it builds a set of weights. So these weights, you will set a heavier weight for your own index. So as you can see, the first team weight vector, the I I equals to 0, or let's say the first person, his weight is very huge. Then compared to the rest is 6, 5, 4, 3, 2, 1, 0 respectively. So for the first round, you actually have the first person versus the 8th person, and respectively. So they use the minimum weight and the maximum weight to match each other, and the higher weight will be added to those that they have matched before. So kind of like a rough understanding of code is. So the counter here used is actually the collections library, the counter method. So let's say two of the things that they're gonna base this upon is whether or not they've played with each other and whether or not they have a higher score, which I mentioned earlier, which is the Swiss point given to each person who wins. So you can see here if the counter is more than 0 and if it's less than the max of the value, then basically this will determine based on two aspects, which is the importance and the closeness, based on the weights. Yeah. So the weights is added every time based on how many times you win, and based on whether or not you've played with that person before. So what happens when we have constraints? This is real life. Like example, don't know how many of you all play Dota, but yeah, this is one of the biggest tournament in the world with the biggest prize pool. So actually, one of the constraints is they have 4 days of group stages, and they leave the last day for tiebreaker, so they only left 3 days to play their group matches. So they have to intentionally match so that, cause in a group they have nine teams. So let's say you want them to play same number of games per day, and fight each team at least once. So it leads out to 3, 2, 2, 1. So you play 3 matches, 2 matches, 2 matches, and 1 match. So there'll be one day they'll play 3 matches, and the last day you play 1 match. So it has to be fair. If not, like, teams can complain about fatigue level for playing like more games than the rest in a day. And this group stage is very important because it defines who goes on to the next stage, which is the winner bracket and loser bracket respectively. So yeah.
Okay. Actually, initially we wanted to discover what the algorithm is behind scheduling EPL fixtures, but we realized that it's actually way more complicated than we actually know. And then it's also not commercially available to actually know. They actually don't review their algorithm because of the commercial value behind it. Because there are a lot of other constraints to add in when scheduling like fixtures for sports. Like stuff like the teams from the same city cannot play at home together and stuff like that, yeah. So in Major League Baseball, we also see the same problem. But one thing special about Major League Baseball is that they have this constraint where teams cannot travel more than 50,000 miles over the course of the season. So this is something like the traveling salesman problem that we discussed earlier, like in the previous weeks. Yeah. And they actually currently have an algorithm which actually took about 10 years to build. And the reason behind this, they say, is because computers are now 1,000 times faster, as well as the software is also faster. And together, that makes the algorithm better than a human now. Yeah, but because they actually charge MLB a lot, so MLB tried to create their own algorithm, but they failed. And so now they still have to continue purchasing it. Yeah. And so if you can actually solve these problems, you get rich. Okay, thank you.
Any questions for Jerome and Randy?
Actually, the Swiss problem, right? If the strong keeps playing against the weak, then the strong will keep winning.
Because so it's widely used in chess. Cause like let's say after you win the second round, right? I mean after you win the first round, then the second round you match with someone that lost to someone earlier on, right? But that doesn't mean that you are better than that person that lost. Yeah, you know what I mean? Like this is also to speed up the process. So you will have like a more clearer bracket